Hello and welcome back to this channel. Dear students, today's topic is types of number system. It is the topic from the subject Basic Electronics Engineering for the first year engineering students. First of all, what is the meaning of number system? It is basically collection of digits and it is denoted by NB. So you might have observed this type of notations like this. So it is 1001. This collection of different notations, in this case this collection of different digits is known as a particular number system. We'll be discussing different types of number systems used in this subject. These number systems are decimal, binary, octal and hexadecimal number. Now the notation used in this case is n. N represents a particular number and this B is known as a base. It is one more name is there. It is also known as a radix. So B represents base or it represents radix. What is the base? The number of possible symbols used in a particular number system is known as a radix or the base. For example, if I am using this type of some code word, then there are only two possible levels, either 1 or 0. So the base of this particular system is 2. Likewise, depending on the base, different systems are there. So without wasting the time, let us discuss all the systems. Before discussing the system, you should know some basics of the number. A very simple thing. Suppose I will consider one number 6789.9. Then this number 6 is at the leftmost side of this system. It is known as MSB, most significant bit. The number which is at rightmost side is known as LSB, least significant bit. Everyone knows this is the decimal point. The numbers which are before the decimal point represents integer part, whereas the number after decimal point represents fractional part. There can be n number of digits after this fractional fractional part, as well as there may be n number of digits before this decimal point, which represents the integer part. Now consider the same example. So we are talking about first type of number system, that is a decimal number system. As we discussed, each and every number system has some base. In case of decimal, the base of this number system is 10. This is the number system which we use in normal cases. So there are, since the base is 10 different symbols are used, and it's very simple. The numbers 0 to 9, these numbers are used as a symbol to represent a particular thing. So base of this particular number system is 10. Now consider the same example which we discussed right now. Say number is 6789.9. So this is the decimal point. How to represent it using decimal number system? We know that in decimal number system, the digits are, everything is known as, 0, 1, 2, 3. This each thing is known as the digit. So they are from 0 to 9. Now how to represent it? Whatever digits you are getting after decimal point, everything is multiplied like this. This is the decimal point. First thing is getting multiplied by 10 raised to minus 1. If there is one more number, say 1, it is getting multiplied by 10 raised to minus 2. One more number is there, say 2, it is getting multiplied by 10 raised to minus 3, and so on. Presently we have only one number, that is number 9 after the decimal point. So it will be getting multiplied by 10 raised to minus 2. Next number 10 raised to minus 2, 10 raised to minus 3 and till infinity. The numbers which are before the decimal points are getting multiplied with 10 raised to 0, 10 raised to 1, 10 raised to 2 and 10 raised to 3 up to infinity. So very simple now. See, as I mentioned, in normal cases we use the decimal number system. So everyone knows how to read this value. It is basically 6789.9. That is the way how to read it. How to represent it? As I have written all these values are basically getting multiplied with corresponding number. So these values are also called multiplying factor or weighting factor. How to do it? See, after decimal point, the number is 9. It will be getting multiplied with 10 raised to minus 1. So for this number, I will write 9 into 10 raised to minus 1. So this mathematically it can be simply written as 9 upon 10 because 10 raised to minus 1 is 1 by 10. So it represents 0.9. Then this number which is just before this decimal point, it again 9, but it is getting multiplied with 10 raised to 0. Anything raised to 0 is always 1, so 10 raised to 0 is 1. So that means this 9 is getting multiplied with 10 raised to 0, that is 1. So it becomes 9 into 1, that is equals to 9. So value of this is 9. Similarly, this 8, look at this number system. Above this 8, I have written 10 raised to 1. So this 8 will get multiplied with 10 raised to 1. So it becomes 80. 8 into 10 raised to 1, that is 80. Second thing, 7. Above this 7, I have written 10 raised to 2. So this 7, this is for 8. This 7 is expressed as 7 into 10 raised to 2. That is 700. 10 raised to 2 is 100. So 100 into 7 is 700. Then above 6, I have written 10 raised to 3. So it will be 6 into 10 raised to 3, that is 6000. Now actual number is obtained by adding all these things. What I did, I have written the number as it is, then I have written the multiplying factor, weighting factor above each number. Accordingly, that particular value is getting multiplied by the corresponding multiplying factor. These values 10 raised to 3, 10 raised to 2, 10 raised to 1, 10 raised to 0 and so on. These values are called multiplying factor. So final answer is add all the values which you got after multiplying. So it is 6000 plus 700 plus 80 plus 9 plus 0.9 and it represents this given number, that is 6789.9. This is the case as far as the decimal number system is concerned. As I mentioned, this is the simplest number system. Everyone is aware of this, but as far as the electronic subject as well as computer subjects are concerned, there mainly the second type of system is used, which is known as the binary system. So it is the binary number system. As the name indicates, bi means 2. So base of this system, that is b is equals to 2. What the base indicates? Base represents how many bits are used to represent a particular value. So we need to use 2 bits and these bits are 0 and 1. So as I mentioned in the earlier example, if you write the symbol like this 1 0 1 1, so the things are either in the form of 1 or zeros. This particular thing is known as the binary number system. Now from the exam point of view, you should know some terms related to binary number system which I have already written. Each digit is known as the bit. For example, if I am talking about this number 1011, this 1 represents a bit, 0 represents another bit, then third 1, fourth 1 represents a different bits. So each digit is known as the bit. If there are 4 bits like this, 1011, how many bits are there? There are 4 bits. This combination of 4 bits is known as the nibble. Then if there are 8 bits, for example 1101 and 1011, if this represents certain information, basically these number systems are used to represent certain information. So if there are 8 bits, the combination of 8 bits is known as a byte. Then if there are 2 bytes, that means if there are 16 bits, each byte represents 8 bits. If there are 16 bits, that means 2 bytes, it is known as a word. And if there are 4 bytes, that means if there are 2 words. So in another language, if there are 32 bits, then it is known as a double word. So these are the different terminologies used in binary number system. Now, as I mentioned, this is the most commonly used number system in the microprocessor, microcontroller, computers, and so on, even in mobile communication. Just for your information, whatever messages we are sending from one mobile to another mobile, these messages are not getting directly transmitted in the form of English text, but that every message is getting converted into different thing which we call it as a code word. It is having some numbers like 1011 and so on. Okay, so how to represent the binary number system? Let us take one example. If I will consider 1011 point, or let us consider one simple example, 1001.101. Now, like the previous case, what I said, the bits before the decimal point represents integer part, after the decimal points represents the fractional part. In the previous case, we choose the multiplying factor which was 10 raised to 1, 10 raised to 2, or 10 raised to minus 1, 10 raised to minus 2, and so on. Since this is the binary number system whose base is 2, everything will be in powers of 2. For example, this is the decimal point, so first bit, this one, for this one I will write multiplying factor by 2 raised to minus 1. For the 0, multiplying factor will be 2 raised to minus 2. For this 1, it is 2 raised to minus 3, and so on. This one is just before the decimal point. The multiplying factor will be 2 raised to 0. This is 2 raised to 1. This is 2 raised to 2. This is 2 raised to 3. Now, how to represent this system? Like the previous case, everything, this, I mean, the given number starts from this value 1. It will be getting multiplied with 3. So, first will be 1 into 2 raised to 3. So, you need to calculate 2 raised to 3, that is 8. So this represents number 8. This is 0. I have written this value for first number, that is 1. Second thing is 0. 0 into 2 raised to 2, that is 0 into 4 becomes 0. So this value is 0. This value is again 0. 0 into 2 raised to 1 becomes 0. This value is 1. It is getting multiplied with 2 raised to 0. Something raised to 0 is 1. So it becomes 1 into 1. So this value is 1 into 1. That means it represents value 2. Decimal point remains as it is. Oh, sorry. This is 1 into 1 represents 1. Decimal point remains as it is. This 1 is getting multiplied with 2 raised to minus 1. So this value, I will write it like this. 1 into 2 raised to minus 1. Everyone knows 2 raised to minus 1 is 1 by 2. So it becomes 1 by 2. That means the value will be 0.5. This is 0. It will be getting multiplied by 2 raised to minus 2. So 0 into anything is 0. So it represents 0. This one gets multiplied with 2 raised to minus 3. So it is same as 1 upon 2 raised to 3. That is 1 by 8. So this value will be 0.125. Now how to write the final answer? Add all the values which are present, which we got after doing this calculation. Add all the values before the decimal point. So before the decimal point, I have one value, that is 8. These values are 0, so I will write it like this. 8 plus 0 plus 0 plus this value is 1. Point. This is the decimal point, which I will write it as it is. Add all the values, all the answers, whatever you got after doing calculations. So first value is 0.5, second is 0, third is plus 0.125. So total thing will be 9.625. This is the common system which we use, which is known as the decimal number system. So base to this is 10. This is the way, if you have some binary number, how to calculate its decimal equivalent, which is required in normal calculations. Next is BCD number system. Actually, it is not new number system. It is the part of or extension of binary number system. This system is also known as 8421 code. Do remember this thing. 8421 code is also a BCD number system. In case of this number system, to represent any decimal value, 4 binary bits, combination of 4 binary bits are used. Now, what will be the total possible combination? As I mentioned, this is basically a binary system. So its base is 2. The 4 bits are used to represent any decimal number. So it will be 2 raised to 4. That represents 16. So there will be total 16 possible combination. So it is represented like this, base is 2 because we are using binary things. Then 4 bits are used to represent a number. So it is 2 raised to 4. That means 16 possible combinations are there. Now, how to generate such tables? There are very simple clues. I have written few decimal values. As I mentioned, there will be 16 possible levels. So I have started from 0, decimal number 0, and it will be 0, 1, 2, 3, this is 9, up to 15. Because if you write the numbers from 0 to 15, total will be 16. Because you are not starting from 1, you are starting from 0. So I have written it till 9, it can extend till 15. So there will be total 16 combination. One important rule is that to use the BCD numbers, only up to 9 numbers are used. Okay, I will explain you how to write this table. It's very simple. As we discussed, this is also known as 8421 code. First decimal number is 0. So since it is 0, this is 8421 code in which 0 is not there. So I have written all the values 0. Because as I mentioned, 4 bits are used to represent one particular decimal number. So for 0, there will be 4 zeros. For 1, look at this system. How to represent it? It is 8, then 4, then 2, 1. This is the way how to represent it. What is the number? It is 1. So this one, below this one, I will write this value 1. See, you need to have to make use of either 0 or 1. If you write 0, 0 into 1 will be 0. So I have written 1. For this 2, I want 0. For 4, I want 0. For 8, I want 0. So it will be actually 0 into 8, 0, 4 into 0, 0, 2 into 0, 0, 1 into 1, 1. So total number will be 1. So its value is 0, 0, 0, 1. Likewise, for 2, again make use of this system. Wherever 2 is there, now make it very simple. Wherever 2 is there, write 1. For all other things, write 0. So this is 0, 0, 1, 0. Consider any example like 6. If I am talking about 6 number is not there. How to represent it? 6 is basically addition of 4 and 2. So for 4 and 2, I will write 1, 1. For other things, I will write 0. So it is 0, 1, 1, 0. So for 6, I got 0, 1, 1, 0. Same thing, similarly, you can extend this value. You can write the value for any decimal number. Now, directly without doing calculation, again, if you are finding it is tough or time consuming, without doing calculation, if you want to memorize, if you want to remember the table, how to do it? I will tell you simple clue. Actually, this is the table for 16 numbers. So values will start from 0, it will be till 15. There will be 4 bits because this is the BCD number system. In BCD, 4 binary digits are used. So start from 0, 0, 0, 0. If you are talking about this column, go on writing 0, 1, 0, 1, 0, 1, 0, 1 alternately till the end. I have written the table till 8 or till 9, I will do it. It will be continuing till 15. About second column. See, for first column, what I said, right, go on writing, first write 0, then 1, 0, 1, 0, 1, 0, 1, go on writing it alternately till the end. For second column, write 2 zeros, 2 ones, again 2 zeros, 2 ones, again if you want to proceed further, so it is again 2 zeros, after that 2 ones and so on. This is about the second column. For first column, alternate 0, 1. For second column, 2 zeros, then 2 ones, again 2 zeros, 2 ones and so on. Third column, 4 zeros, 4 ones, again 4 zeros, 4 ones and so on. Last column, first column from left hand side or last column from right hand side. Write 8 times 0, that means from 0 to 7, 8 times 0 and then it will be 8 times 1 like this. But in this case, we are representing a decimal number in the form of a combination of 4 binary bits. So numbers till 0 to 9 are allowed. After 9, actually table will be till 15. After 9 till 15, the values are not allowed. Let us take one example. If I want to represent 124 whose base is 10, that means this value 124 is expressed in terms of decimal point. If I want to express it in BCD form or 8421 code, how to do it? The number is 124 to the base 10. Now, for this one, it's very simple now. Once you generate this table, the remaining things are very simple. For 1, look at the table. What is the value? It is for 1. I have written 0, 0, 0, 1. So this will be 0, 0, 0, 1. For 2, what is the corresponding value? It is 0, 0, 1, 0. For 2, I am referring this value. For 4, what is the corresponding value? This value. So it is 0, 1, 0, 0. So this is the case. I mean, this decimal number is represented in the form of binary like this. If you again don't want to refer the table, you can directly make use of this system as I mentioned earlier just now. Again, you can represent any bit like this. For example, 2, for this to represent 2, this should be 1, all other things will be 0. That's what we got. For 4, this should be 1, all other bits will be 0. So it is 0, 1, 0, 0. That's what we have written here. Likewise, you can generate it for anything. So this is the case for BCD number system. The third number system is octal number system. Octal means 8. So it's very simple like the previous two number systems. Octal means 8. So base of this number system is 8. Now let us directly talk about one example. Suppose I have this number 4321.471. I have to represent it using octal number system. So how to do it? Since the base is 8, this decimal point I will keep it as it is. After decimal point, every value will be multiplied with 8 raised to minus 1, 8 raised to minus 2. This value will be multiplied with 8 raised to minus 3 and so on. Values before decimal point will be getting multiplied with 8 raised to 0, then 8 raised to 1, 8 raised to 2 and 8 raised to 3. So rest all the things are similar to the previous case. Now this answer I can write it like this. For this it is 4 into 8 raised to 3 plus 3 into 8 raised to 2 plus this value is getting multiplied with 8 raised to 1. So 2 into 8 raised to 1 plus 1 into 8 raised to 0. 8 raised to 0 is 1. Decimal point remains as it is. After decimal point, this 4 I will write over here. This 4 is getting multiplied with 8 raised to minus 1, that is 1 by 8, plus this 7 is getting multiplied with 8 raised to minus 2, that is 1 by 8 square, plus this last one will get multiplied with 8 raised to minus 3, that is 1 by 8 cube. If you solve this on the calculator, this answer will be 2257.61132. This is in the normal format, in the decimal format. So after the bracket, I will write the answer in the bracket and write its base as a 10 because we have converted this into the decimal number system. So this particular number system is known as the octal number system. How to remember it? Octal means 8. So base of this number system is 8. Now last type of number system is hexadecimal number system. It is simply known as hex number system or hexadecimal number system. In this case, the different combination of 4 bits of binary systems are used. So this is also known as abbreviated form of the binary system. There are total 16 bits used to represent the system. So base of this system is 16, but we know that if we are talking there about 16 numbers, the total possible combination will be from 0 to 15, but only numbers from 0 to 9 are used. After that, 10 is represented by letter A, 11 by letter B, 12 number by letter C, 13 number by letter D, 14 number by letter E, 15 number by letter F. So as I said, only 0 to 9 bits are used because they are equivalent to the binary decimal number system. After that, 10 means A, 11 means B and so on. And the base of this hex system, hexadecimal system, is 16. Let us consider one example. Suppose the value is A3D.84. This is just one example, A3D.84. Now we know that A means 10, D means 13. So this value is actually 10, this value is actually 13. How to do it? This is the decimal point. So after decimal point, this first value, for first value multiplying factor will be 16 raised to minus 1. For this second, it will be 16 raised to minus 2. For this, it will be 16 raised to 0. For 3, it will be 16 raised to 1. For 1, it will be 16 raised to 2. So, for A. Now, value of A is 10. So, how to calculate this value? It is 10 into 10 raised to 2 plus 3 into 16 raised to 1. This is not 10. It is 16 raised to 2. So, actually it is A means 10 into 16 square plus 3 into 16 raised to 1 plus D. D means 13 plus 13 into 16 raised to 0. 16 raised to 0 is 1. So, it is 13 point. This 8 into 10 raised to minus 1. 4 into 16 raised to minus 1, 4 into 16 raised to minus 2, and so on. So if you solve this on the calculator like the same as the previous case, the answer will be 2621.515625, and this is in the form of decimal, so its base is 10. So these are the four basic number systems used in this subject. In the next session, which will be the most important section, I will teach you how to convert the number from one number system to the another number system. So that's it for today's session. If you like this video, don't forget to smash the like button. Thank you. Thanks a lot.